Hey everyone, it's Justin again. In this lesson, we're going to be taking what you learned about similar figures a few units ago and applying that in 2 dimensions to area. By the end of this lesson, you will be able to use the relationship between the scale factors of areas and side lengths of similar figures to find missing areas, side lengths, and scale factors. First, we'll explore the relationship between the scale factors of side lengths and areas in similar figures. Next, we'll determine a rule that applies to all similar figures. And finally, we'll complete 2 example problems. If you think back to our unit on similarity, we learned that similar figures are 2 polygons of the same shape with congruent angles and sides that are proportional. We also learned that the proportional relationship between their side lengths can be represented by a scale factor. In this case, going from this small triangle to the big triangle, there's a scale factor of 2 for the side lengths. But what about their areas? Do those have the same scale factor? Is it different? Well, this is exactly what we want to find out in this lesson. Let's play around with some similar triangles to see if we can figure this out. At the beginning of your Notes template PDF for this lesson, there is a guided exploration in GeoGebra. The goal of this exploration is to answer this question. How does the scale factor of the side lengths of similar figures affect the relationship between their areas? Pause the video here and come back when you've completed this exploration. I went ahead and completed the same exploration that you did, and since I was trying to figure out the relationship between the scale factor of the side lengths and the scale factor of the areas, I put them together in a chart so that I could see them easier. When I opened the GeoGebra, the scale factor of the side lengths was 2, and the scale factor of the area was 4. When I manipulated my triangle and changed my slider, I used a scale factor for the side lengths of 5, and the scale factor of the area was 25. For my third experiment, I used a scale factor for the side lengths of 3, and the scale factor of the area was 9. I think I've gathered enough information to help me come to a conclusion, so let's clear out some room and make this chart bigger. What's the relationship between these 2 lists? How do I get from the side length scale factor to the area scale factor? Okay, well, let's think about this. How can I get from 2 to 4? Well, I could add 2. This relationship should work for all of these examples, though, and 5 plus 2 does not make 25, so that doesn't work. What else could I do to get from 2 to 4? I could multiply by 2. That works, but now then I have the same problem as last time. 5 times 2 does not make 25, and 3 times 2 doesn't make 9. So multiplication also won't work. What other type of operation could I use to get from 2 to 4 to test out? Oh, what about squaring? 2 squared makes 4, 5 squared makes 25, and 3 squared makes 9. Hey, this works. You know, this makes sense because area is a square measurement. Let's take a look at something like a square. One square has a side length of 4 units, and the other has a side length of 12 units. So the scale factor between the side lengths is 3. That means I can rewrite the larger side length as 4 times 3 units. The area, length times width, of the smaller square is 4 times 4, or 16 square units. When I go to find the area of the larger square, I wind up multiplying in this scale factor twice, once for the base and once for the height. With a little bit of rearranging, we can see how that scale factor of 3 becomes 3 squared in the area equation for the larger square. Since all polygons are 2-dimensional, this same thing happens when you're calculating the area of any figure. Now let's write a rule that we can use to help us in our practice. The scale factor of the area of two similar figures is the square of the scale factor of their side lengths. When you put this in your notes, make sure you write it in a way that will make sense to you when you come back and reread it. It doesn't even have to be written out in words. You might want to try writing it out as an equation, turning it into a drawing, or anything else that will help you make sense of it later on. Now, what can I do with this? Let's try it out. Our first example problem tells us figure A is similar to figure B. Solve for x. Okay, let's take a look here. I have two corresponding side lengths. I know the area of figure B, and oh, here's x. I need to find the area of figure A. Do you have any ideas on how we can start? Did you notice that since I have two known corresponding side lengths, I can figure out their scale factor? Well, let's start here. We could choose to do this in either direction, but most people tend to like whole numbers more than fractions. So what would you multiply times 3 to get 12? Yeah, 4. So the scale factor for the side lengths is 4. We can use this to find the scale factor of the areas. Take a look at those notes you took in our area of similar figures rule. If the scale factor of the side lengths is 4, then what is the scale factor of the areas? We have to square the scale factor of the side lengths. So 4 squared gives us 16 for the scale factor of the areas. It might be helpful to add this into our picture to help visualize it. Okay, so since the scale factor of the areas is 16, that tells me that x times 16 has to give me 352. Now we can set up an equation to solve for x. Pause the video now to write and solve this equation yourself. Did your equation look like this? Nice job. Then we divide by 16 on both sides. We get x equals 22. Let's double check. Is this our final answer? Yep, the problem said to solve for x, so this is our final answer. Let's do one more example problem. Our next example problem looks pretty familiar. Figure G is similar to figure K, and we need to solve for x. The difference is that this time x is a side length, and we do have the area of both figures. Do you have any ideas about how we can start this problem? Since we're trying to find a missing side length between two similar figures, we're going to be using scale factors in this problem. Which scale factor can we find right now? The area or the side lengths? Yeah, since we have both areas, we can find their scale factor. Pause the video now and find it. You are welcome to find your scale factor going from figure G to K or in the other direction. As long as you're consistent throughout the problem, it's going to be fine either way. I like to find the scale factor going from the smaller figure to the bigger figure, so my goal was to figure out what do I multiply by 20 to get 125. I can't think of any number that I can multiply by to do that off the top of my head, but I could set up an equation to figure it out. Be careful here. I do not want to use x in this equation since x already has a place in the problem. Instead, I'm going to be using s for scale factor. Pause the video here to set up and solve an equation now to find the scale factor of the side lengths. So, 20 times s has to make 125, which looks like this as an equation. If I solve here, I can see that the scale factor is a decimal, 6.25. Let's make our chart to organize ourselves here. I need to find the scale factor of the side lengths. So I'm kind of working backwards here. I know that to get from the scale factor of the side lengths to the scale factor of the area, I square my number. What do you think I could do to go in the opposite direction? Are you thinking that since we're going in the opposite direction, we should use an opposite operation? That is definitely correct. what would be the opposite operation of squaring? Taking the square root. We're going to need a calculator for this one. What's the square root of 6.25? Oh, 2.5. We know that the corresponding side length to x is 5 meters, and we know that the scale factor is 2.5. Pause the video here and see if you can solve for x. Looking at this visually always helps me. I can see that this relationship makes this equation. Solving gets me that x equals 2. And since our problem asked us to find x, this is our final answer. Let's take some time to summarize what we've learned here. We were able to discover the area of similar figures relationship together. If you square the scale factor of the side lengths of two similar figures, that will give you the scale factor of their areas. When using this relationship in problems with similar figures, a useful strategy is to find one of the scale factors either for the side lengths or the areas. Once you have one scale factor, you can use their relationship to find the other one. You can also use your scale factors to set up equations to find missing values. You'll find the problem-solving strategy list on the last page of your notes template PDF for this lesson. Be sure to keep it handy so that you can look at it if you need more guidance during your practice game. Good luck, and I'll see you next time!